Morning everyone, this is Logic Coding. Today we're going to look at another backtracking problem called permutation. So permutation and combination is a type of problem that backtracking and recursion can give us all the possible results. So in this one, it's pretty straightforward. We're given a vector of integers, array of numbers of distinct integers. So every number is distinct. And I want to return all possible permutations. You can return the answer in any order. For example, if we have 1, 2, 3, we would have 6 different possibilities. In the first position, we can either place 1, 2, 3. So in the first position, I would have n choice, and then in the next position, because we have already used one possibilities, I only have n minus 1 choice, and then until the last position, I just have 1 choice. Cool. Then to do this, we can build a backtracking function. And at the first index, I have n choice. I can iterate from the very first to the very last. I can swap them. So I have n choice. And then the next is I plus 1. In the next choice, because the first is already fixed, then I can only swap my second with the rest of them. So as always for backtracking, before we do the implementation, let's look at the time complexity. The time complexity would be n factorial, as I just described, and the space complexity would just be O(n) because of the recursion stack. Now, let's look at the implementation. So as always, we first declare a solution holder. Whenever we meet the end condition, we just append the current permutation to the answer. And then we define a backtracking function which takes the numbers, the current position, this I index, we start from 0, and then the solution holder. So now let's define this backtrack. I have my numbers, I have my index, and I have my solution holder. So if my index reaches to the last, which means I'm done with the current one, so answer would be push back the current numbers and just return. Otherwise, at this position, I have from it to the end choice. So I start from the index, I end with its size, I++. At each I can swap my current with I. Of course, I need to swap it back, but in between, I can continue my search parties for the next position. Answer. So in this way, at each level, the choice will be decreased by 1, and until we reach the end, we can explore level. Yeah, I think that's pretty much it. Again, it's a template question for backtracking, but it teaches how to do the DFS in the solution space and practice on the recursion structures. We have an end condition, and at each level, we have some certain constraints. For this one, we actually do not have any constraint, and we do not any duplicates. But we still have the outer for loop for all the possible choice, and the action for the current level. Continue this call the recursion function and backtrack. Let's try and run the code. Try and submit it. Looks good. Cool. This is very similar to the video that I just did called Generate Parenthesis and Letter Combination. And I'm going to, let me double check of the time and space complexity. Oh yeah. So if we consider our answer also as the space complexity, then we do need n factorial space as well. Yeah. So answer is also n factorial. Try. Okay, cool. But if we do not need to consider everything, then I'll just say it's OM because it's actually it's O1 if we do not need anything. But the answer itself will hold n factorial time. That's it. Thanks for watching. See you next time.